Good morning. Let's go ahead and finish up the semester. What we have here now, we'll just have to do chapter 6. There's only two sections, section 1 and section 6. They both deal with solving what are called systems of equation. A system of equations is when you have two or more equations with two or more variables. So whenever we have two or more variables or two equations, we have certain possibilities that can occur. Possible outcomes. We really have three when we count the number of solutions. They can be parallel. And that equals no solution. Now, you have two lines that are parallel that you have parallel lines if you end up with a non-equality. In other words, if you end up with something like 3 equals 0, after everything is we solve for everything and we come up with 3 equals 0. Since that doesn't equal, then we know they're parallel. The next one, this is line 1, this is line 2. What if line 1 and line 2 are the same? Same line, we have an infinite number of solutions. All right. And then anything else will have one solution. These are the only three things that we can have. So when you have infinite solutions, you have the same lines if you end up with 0 equals 0. Everything else is gone. You end up with 0 equals 0. That means no matter what you put in there, it'll give you the same answer. You have only one solution if you end up with x equals a number and y equals a number. That is your solution. All right. If they have a solution, they're called consistent. words, consistent if you have one or more solutions. They're consistent. So where they meet, that's if they meet once, they're consistent, or if they have infinite solutions, they're consistent. That means if they don't meet, they're called inconsistent. All right. If they're the same line, they're called dependent. So that means if they're different lines, they're independent. Because if they're the same line, what the equations are the same and one equation depends on the other equation. But if they have either infinitely many or one solution or no solutions, I mean, if they have only one solution or no solutions, they're independent because the lines travel independently. So if we're talking about dependent, if the lines are the same. Right. So let's look at all these examples now. What we're going to do here, we have four methods to solve a system of equations. The first is graphing. This is when you graph the equations on the same chart. And you see if they meet, if they're the same, or if they're perpendicular or parallel. So that's the first one. It's only as good as the graph. Because if the two lines intersect and it's not at a specific point, if it's in, and you won't know exactly where it sits. So it's only as good as the graph. The next method is called substitution. This is when you solve one equation for a variable. Plug that variable into the other equation. And solve for the remaining variable. Then take the last solution and plug it into the first step equation. That will give you the value of that variable. That's substitution. Third method is going to be called elimination. Here, you set both equations to standard form. Choose a variable to eliminate. If needed, you can multiply one or both equations whatever numbers needed to have opposite coefficients. Then add the two equations together and solve for the remaining variable. Then plug that solution into either of the original equations. Okay, so we'll start off with those. And then we'll talk about the fourth method is called Cramer's rule. And this uses matrices to find the solutions. All right, so I'm going to use two, maybe three examples, and we'll go through all four methods. So let's use this first one. We're going to use x minus y equals 5, 2x plus y equals 1. This is line 1. This is line 2. So the first method is graphing. Remember, to graph, we have to put them in y equals mx plus b. So this first one, we get, I'll move the y over and then 5. So we have y equals x minus 5. And this one, I'll just move so it's y equals negative 2x plus 1. I'll just move the 2x over. So line 1, we have it at 1, 2, 3, 4. At -5, we have the y-intercept. And the slope is 1 over 1. So up 1 over 1. Connect the dots. Line 2, its y-intercept is positive 1. Slope is down 2 over 1. So we're estimating that where this line intersects is that going to be at 2, -3. So I'm saying is if your graph isn't, if these spaces aren't equal, you have a different graph. So it'll be horrible. So this is line 1. This was line 2. Where they intersect is my solution. The second method will be substitution. So we have x minus y equals 5, 2x plus y equals 1. Line 1 and line 2. So I could choose either equation and choose for a variable to solve for. So I use line 1. I'm choosing line 1, and I'm solving for x because it's easiest. All I have to do is move the y over. So I have x equals y plus 5. We'll come back to this from the other x value later on. All right, so now we know that x equals y plus 5. So we now, since we used line 1 here, we go to the line 2, which is 2x plus y equals 1. Anywhere I see an x, I know the equation is y plus 5. That's the substitution part. So now I solve with line 2, I solve for y. So I have 2y plus 10 plus y equals 1. Combine like terms, 2y plus y is 3y plus 10 equals 1. Subtract 10. 3y equals -9. Divide both sides by 3. -9 over 3 is -3. So there's my y value of my intercept. To find the x value, I take this and go back all the way up to this one to find my x value. So we have x is equal to y plus 5. Y we know is -3. -3 plus 5 is 2. So our solution is 2, -3. That's substitution. Again, it's easy because there aren't any fractions in there, but if we had fractions, it would be a little bit more difficult. Now let's do it with elimination. We have x minus y equals 5, 2x plus y equals 1. Remember, in the elimination, we have to choose a variable to eliminate. To eliminate it, they must be opposites, must have the same number, but different signs in front of it. So as we can see here, the coefficient of y, this one's -1, this one's +1. So in here, if I just go ahead and add these two lines together, x plus 2x is 3x, -y plus y cancel, 5 plus 1 is 6. 6 divided by 3 is 2. There's my x value. Now, since I used both equations at the beginning, I can plug this into whatever one makes it easier for me to solve for. So I'll plug into line 1, which is x minus y equals 5. So when I see x, that's 2 minus y equals 5. Subtract 2. -y equals 3. Change the signs. Y equals -3. So x is 2, y is -3. It doesn't matter even if you chose line 2 to plug it in there. So we're going to put anywhere seeing x, you put a 2. So it's 2 times 2 plus y equals 1. 4 plus y equals 1. Subtract 4. So y equals -3. Same thing. So it doesn't matter how it works. All right, so let me look at another one here. Let's look at example 2. Let's use this equation. 4x plus 3y equals 11. -5x plus 2y equals 15. This is line 1, this is line 2. So the first one we use graphing. So we have to take both of these equations, solve for y. We have to put them in y equals mx plus b. So let's move the 4 over. So it's 3y equals -4x plus 11. Divide by 3. See, now I wouldn't even go any further with this because I know my graph is going to be horrible because how would I find that x-intercept? Or that y-intercept mean? And likewise on this side, I have 2y equals 5x plus 15 divided by 2. Y equals 5 over 2x plus 15 over 2. Here we have another one that has fractions. So I wouldn't use graphing in this one. Just use substitution. We have 4x plus 3y equals 11. -5x plus 2y equals 15. Line 1, line 2. So I will take the second one. I'll take line 2, my first step. Take line 2. I'm solving for y. So I move the x over, so I have 2y equals 5x plus 15 divided by 2. So there's my formula for that one. Since I used line 2 here, I now got to go to use line 1, which is 4x plus 3y equals 11. Anywhere I see a y, I put that in its place. You only have one equation, one variable. We have a fraction and equal sign. So the LCD is 2. I multiply each of these terms by 2. This one cancels. So we have 8x plus 3 times 5x plus 15 equals 22. Distribute, get rid of the parentheses. So we have 15x plus 45 equals 22. 15x plus 8x. Let's go over here. 15x plus 8x is 23x. Subtract 45 from both sides. 23x equals 45 is bigger. 45 minus 22 is 23. X equals -1. Now, since I know what x is, I can plug this thing back into this equation, the very first step equation, to find y. So it's y equals 5 times -1 plus 15 over 2. -5 plus 15 over 2. 15 minus 5 is 10 over 2. Y equals 5. So my intercept is that. Now let's do the elimination. We have 4x plus 3y equals 11. -5x plus 2y equals 15. So I'll pick a variable to eliminate. I'll pick y. I choose y. So what has to happen is the coefficients have to be the same number but different signs. So what I do to the first equation, I multiply that one by 2. Since they're both positive, I multiply the second one by -3. So that'll give us 8x plus 6y equals 22. Negative is positive. 15x, that's a plus. Negative positive is a negative. 3 times 2 is 6y. -45. Add the 2 lines. The y is disappeared. So I have 15 plus 8 is 23. -45 plus 22, so it's -23. So x is equal to -1. Since I know what x is, and I used both equations to get where I am here, I could choose either one of the equations. It doesn't matter. So let's use line 2. -5x plus 2y equals 15. We know what x is. We have to solve for y now. So anywhere I see an x, I put a -1. Negative, negative makes it positive. Subtract 5. And divide by 2. My solution is there. All right, let's see what it would look like if we had a parallel or a perpendicular line, or the same lines. Let's use this equation. X minus 3y equals 1. Negative 2x plus 6y equals 5. Graphing, I'm not going to go into that. So we're going to do substitution. So here I have line 1, line 2. So remember, I have to choose. I'm going to choose the first line and the first x. I'll use line 1. I solve for x. So I move that over. So x is equal to 3y plus 1. I'll have to come back to this one later. Since I used line 1 for that one, I have to go to line 2. Anywhere I see an x, I put that equation. So -2, in place of x, I put 3y plus 1. Because if you only have one equation, you can only have one variable. Let's solve for that variable. -2 times 3 is -6y. -2 times 1 is -2. Combine like terms. -2 equals 5. So this means the lines are parallel. No solution. And the same thing would happen. Well, I'll show you. Let's do the elimination method with this. So we have line 1, which is x minus 3y equals 1. -2x plus 3y equals 5. I choose a variable. I'll choose x. So I have to have the same number but different signs. So this one needs to be multiplied by 2. And I'll leave that one already since it's -2. It has to be the same number, but different signs. So 2x minus 6y equals 1. So we have 2x minus 6y equals 2. This is line 1. And line 2, I didn't touch, so it's minus 2x plus 3y equals 5. That's a 6. When I add the two lines together, these cancel, these cancel. Not possible, so parallel. No solutions. All right, let's look at what one would look like if it's the same line. Two x plus 3y equals 6. This is line 1. Line 2. 4x plus 6y equals 12. Substitution. I'll take line 1 and solve for x. So I'll move that over there. So I have 2x equals negative 3y plus 6 divided by 2. So x is equal to negative 3y plus 6 over 2. I'll have to come back to this one to find the x value. So now I plug this into the second line. 4x plus 6y equals 12. Anywhere I see an x, I put this equation. So it's negative 3y plus 6 over 2. The 2 and the 4 cancel. So 2 times negative 3 is negative 6y plus 6 times 2 is 12. 6y, so 12 equals 12. Same line, infinite solutions. That's what it looks like. Same thing will happen with the elimination method. Show you. So we have 2x plus 3y equals 6. 4x plus 6y equals 12. I'll get rid of the x. So I have to have the same number in front, but different signs. So that's, if I multiply the first one by negative 2, then I'll have a negative 4. So negative 2 times 2 is negative 4x. Negative 2 times 3 is negative 6y equals negative 12. And line 2, add the 2 lines. The same line. All right, so those are the first 3 methods. Now my favorite. Cramer's rule. A matrix numerical representation of a system. So let's say we had ax plus by equals c, dx plus ey equals f. This is line 1, this is line 2. The way we do with matrices is we don't deal with the variables anymore. Only the coefficients. So the first line, the first column are the x's, the second column is the y, and the last one is the solutions. So we have A, B, D, E, C, and F. This is all we'll be using. Okay, then to find x and y, we use determinants. A determinant, A, B, D, E, is simply multiply those two together first, minus that. So that's the determinant, D. AC minus BD. Now, to find X and Y, we need the determinant with respect to X and the determinant with respect to Y. So dx since we're solving the X column, we take the answers and put them in the X column. Remember, this is the one we'll take the determinant of. So here, I'll have CF, since I'm solving for X, and I leave the Y's alone. B, E. And we do the same way. Multiply these two together first. C times E minus this one. B times F. So my dx is C times E, B times F. My dy I would take the solutions and put them in place of the y's. Leave the x alone. So leave the x alone, so it's AD, and the solutions go in the y column, CF. And we do the same thing. So we have A times F minus C times D. So that's my dy. AF minus CD. To find the value for x, we take dx over d, and to find the dy is dy over d. All right, let's look at the examples that we did. We'll use the same one we had here. The first one, x minus y equals 5, 2x plus y equals 1. So the first thing we have to do is put these into matrix form. Remember, this is the x's, this is the y's, this is my solutions. So my coefficients, 1, -1, 2, 1. And the answers are 5 and 1. So my main determinant, I use the original equation. I use this one. So I have 1 times 1 minus 2 times -1. 1 times 1 is 1, negative. So my D is 3. Now we got to find dx. Since I'm solving for x, I take my solutions and put them in place of x. So it's 5, 1. Leave the y's alone. Five times 1, 1 times -1. 5, negative is positive. So my dx is 6. The dy, I leave the x's alone, 1, 2, and take the solutions and put them in the y column. So my solution is 5, 1. And do the same thing. 1 times 1 minus 2 times 5. 1 minus 10. So dy is negative 9. So to find my x value, it's dx over d. To find my y value, it's dy over d. Dx is 6, d is 3, so x equals 2. Dy is negative 9, d is 3, negative 9 over 3 is negative 3. So my solution is at that value there, which is what we got last time. All right, so look at the next example. We used 4x plus 3y equals 11. 5x plus 2y equals 15. I have to convert these into matrices. So only the coefficients. This is my x's and the y's. 4, 3, 11. Negative 5, 2, 15. So D is the original one. So it's 4, 3, negative 5, 2. Four times 2 minus 3 times negative 5. 8, negative is positive. 15. So D is 23. Dx, I take my answers and put them in the x column. So it's 11, 15. Leave the y's alone. 3, 2. 11 times 2 minus 3 times 15. 22 minus 45 is negative 23. Dy, leave the x alone, which is 4, negative 5, and I put the answers, the 11, 15, in the y column. Four times 15 minus 11 times negative 5, which is this one. 4 times 15 is 60. Negative and negative is a positive. 55. So my dy is 115. X is dx over d. Y is dy over d. Negative 23 over 23. X is negative 1. 115 over 23. So negative 1, 5. We had x minus 3y equals 1. Negative 2x plus 6y equals 5. We have 1, negative 3, 1 coefficients. -2, 6, and 5. So this original one is this one. 1 times 6 minus -2, -3. Negative is a positive. We can't go any further. No solutions, because remember, to find x and y, d, you cannot divide by 0. So that means they're parallel. And example 4, 2x plus 3y equals 6. 4x plus 6y equals 12. Convert this into matrices. 2, 3, 6, 4, 6, 12. So D is 2, 3, 4, 6. It's this one. 2 times 6 minus 4 times 3. Oh, same thing here. Our D is equal to 0. Does that mean it's parallel? Well, let's see. If we solve for dx, so we have 6, 12, 3, and 6. 6 times 6 is minus 3 times 12. 36 minus 36 is 0. So for this one, my x is 0 over 0. What would it be over here? What would my dx be over here? So I put my answers. 1 times 6. 5 times -3. So we have 6 plus 15 is 21. So if you have a number on top, it's parallel and a 0 on the bottom. If you have a 0 over 0, then the same line. Infinite solutions. And it is possible to have larger equations. Let's say we had this. So if we convert this one to a matrix, we have 3 equations, 3 variables. So we have 3, 5, -7, 6. -2, there's no y, and a 4, 1. There's no x. So whenever you have these are called 3 by 3 matrix, because 3 rows, 3 columns. This is number of rows, and this is number of columns. To find the determinant here, start with the first term. Now, since you're using 3, we can't use anything in that row in that column. So we have a smaller matrix, 0, 4, -2, -3. We use the 3. Now, because what it goes is positive, negative, positive. So now we do a subtraction of 5. Since we use 5, we can't use that row or that column. So we have -2, 4, 0, 3. -2, 4, 0, 3. And it's plus -7. I can't use that row or that column, so I have -2, 0, 0, -2. Now I just do the determinants from there. So it's 0 times 3, or times -3, minus -2 times 4, minus 5. -2 times 3 minus 0 times 4. Positive and negative makes it a negative. -2 times -2 minus 0. That's 0, positive. So it's 8. That's 0, so it's -6 inside there. Negative and negative is positive 4, 0. 24, negative is positive 30, minus 28. 30 minus 28 is 2, plus 24 is 26. And that's how you do it. It gets, for dx, you would take the answer, put it in the x column, do the same thing. Remember, it's positive, negative, positive. There's also another way you could do this bigger one. Yeah, we'll say that for another day. All right, that's it for the semester. We're done. Good luck, everybody. Get everything done fast as you can so we can get your exams done by the end of the semester, which is December 7th by 11:59 p.m. Good luck. Happy Thanksgiving. Goodbye.